Okay, year 10. So just before we start today's work, I'm just going to show you the answers to last lesson's tree diagrams exercise so that you can mark it. So I've had a look over them and most of them are really, really good. Just the odd wee mistake. So what I need you to do first of all is to compare your work with these answers, because these are just the answers, not the solutions. And if you can spot where you've gone wrong, if you've gone wrong, perfect. If not, and you can't figure it out, then do come on Google Meet later on and ask me to go over it with you. Okay, so last day it was exercise 3E and it was just questions 1, 2 and 3 that we were doing. So the answer book here gives them in fractions, but a lot of people had done those in decimals, so I've written in the decimal version of those. But as I say, most of them were really, really good, so well done. Get those marked and then let's start on to today's stuff. Right, so this is an extra example that isn't in your notes, so you're going to have to get a bit of paper and a pen, pause the video and copy down the question. Do that for me now. So hopefully you have this question bit written out. If you remember last day I said that we didn't get a chance to do any of those questions where it was an or situation, and this is one of those. So this will be a good chance for us to recap the rules for tree diagrams. Okay, so we've got a class of 20 and 4 of them are left-handed, and then we have another class of 24 and 6 of those ones are left-handed. So one is chosen from each class, so one from the 20 and one from the 24. What's the probability that one of the students is left-handed and one is not? So we're going to draw the tree diagram first of all here. Okay, so let's do the class of 20 first, and we'll go left-handed, right-handed. Okay, so the probability in this class of 20 that someone is left-handed is 4 out of 20, which does simplify down. So that means the probability that someone is right-handed must be 16 out of 20, because remember the total of wee branches like this is always 1. Okay, so that's for the class of 20. For the class of 24, we're going to have the opportunity for someone to be left-handed and right-handed. And then the same again down here. Right, hopefully you can see it a little bit better now. So you're writing this down with me, and remember, pause if you need to. So for the class of 24, we were told that 6 of them were left-handed. So that means the probability of picking a left-handed person is going to be 6 out of 24. And this can be cancelled as well. I'll just do my cancelling at the end or within my working out. Okay, so if 6 out of 24 are left-handed, then that means 18 out of 24 must be right-handed. Okay, so same again on this one. And that. Okay, so I'm going to do my working out over here. You can continue to work on down, whatever suits. So we've been asked, what's the probability that one of the students is left-handed and one is not? Well, this is an or situation because there's 2 different ways that that can happen. So the 2 ways it can happen are that we get a left-handed person from this, and then if we've got a left-handed person here, it would be a right-handed person from this class. Okay, or we're going to pick a right-handed person from this class and a left-handed person from that class. So the probability, let me fix that wee spelling mistake. So the probability that we have got one left-handed and one right-handed, and I'm just simplifying it, writing it a wee bit shorthand, is going to be that it's either going to be this or this. So this first one is that we get from the class of 20 left and someone from the class of the 24 is right-handed, and then or we're going to get the other way around. We're going to get a right-handed person from that and a left-handed person from that. Right, I faffed about for ages here trying to think the best way to word this. So the probability that we get just one left-handed and one right-handed is going to be, there's two ways that can happen. So we're either going to get left-handed from the class of 20 and right-handed from the class of 24, or right-handed from the class of 20 and left-handed from the 24. So this one here, the left from the 20, sorry, and the right from the 24, well, that's an and situation, and that's this yellow path. So that's that one there. So because this is 4/20ths, that we choose left-handed from the class of 20, and remember means multiply, 18/24 is the right from the 24. Or means add. So 16/20ths, that is the probability that we get a right-handed person from the class of 20, and multiply left-handed person from the 24 is 6/24. Now, a couple of people are making mistakes with adding fractions and multiplying fractions, so I'm going to take this opportunity to remind you of that technique here, okay? Before I do anything, I'm just going to simplify these fractions. Okay, so that's these all simplified. 4/20ths simplifies down to a fifth, 18/24, 3/4, etc. Okay, so for multiplying fractions, have a look and see if there's anything you can cancel first of all. So you're going to cancel something on the top with something on the bottom. In this one here, there's nothing I can really cancel. So I'm going to multiply top by top and bottom by bottom. So 1 multiplied by 3 gives me 3. 5 multiplied by 4 gives me 20. Plus, oh, there is something I can simplify here. Look, the 4's. So 4 will go into 4 once and into 4 once. So 1 multiplied by 1 gives me 1. 5 multiplied by 1 gives me 5. Okay. Now with adding fractions, for some reason a bunch of you have forgotten how to do that. Remember, for adding fractions we get a common denominator. So in this case 20 is going to be our common denominator. So that one can stay the same. 1/5. If I'm rewriting that as a fraction over 20, 5 has been multiplied by 4 to give me 20. I do the same here, so 1 multiplied by 4. So that gives me 7/20ths. Now, I am sure you'll agree that is a little bit more awkward than the work from last day. So remember, do make use of that time on Google Meet if you get stuck and you need to ask for help. This is actually one of the questions from the exercise. I think it was question 8, so you'll not have to do that one. But seeing these questions, but just be super careful with what the question even is getting at. So it's, for me, one of the things that I see people go wrong an awful lot with this is not recognising that this would be an or situation. So one of the students is left-handed and one is not. Well, that can happen either way around. Okay, let me just have a wee look at a couple of the questions here with you. Right, so very quickly, if we look at 11, this is all about whether it rains or not. And one of these questions is that we've defined the probability that it'll rain on both days. So that's going to be rain and rain. But just one of the days, well, there's two ways that can happen. Either it rains on Saturday and doesn't on Sunday, or it doesn't rain on Saturday and does rain on Sunday. Okay, so do you see what I mean? And there's lots of that in these questions. Okay, so I will list the exercise in the wee assignment tab, and I'm going to get you to show me this as well. Okay, bye.